Hi, my name is Noah Gift, and I'm the author of this book, Pragmatic AI, An Introduction to Cloud-Based Machine Learning. What I'm going to do is go through some of the ideas that I've explored in this book and also other live seminars that I've given. We're going to go through step-by-step a notebook that shows you all the basics of how to code in Python, from procedural statements to strings to functions. And this is really a bootstrap to get you started on your journey to master Python. Let's go ahead and get started. To start this tutorial, I'm going to go ahead and type in GitHub. I'm going to find functional intro to Python. So here is the repo. So functional intro to Python. That URL is github.com, Noah Gift, functional intro to Python. And if I scroll down here, I'm going to go to this first notebook, which is day one, part one, Google Colab. What's really powerful about these Colab-based notebooks is that you can step-by-step do exactly what I'm doing. You don't have to worry about installing Python, getting it set up. And this is really one of the biggest challenges to learning to program. So we're going to tackle that by just using this execution environment. I'm going to go ahead and right-click on it and say Open Link in New Tab. And then I'll say Open with Google Colab. All right, now that we've started this notebook, let me show you exactly how it's going to begin. So one of the first things that we'll have here is this ability to change the runtime. And I'm going to go ahead and select Connect here. And this just gives us a Python environment, make sure that we're running. Great, it's initialized. And now from here, if I go to runtime and I say change runtime type, you'll see that it's a Python 3 environment with a GPU. So we're ready to go. Now, let's go down here and get started in this notebook. So I'm going to scroll down here. And at the very beginning, I'm going to talk a little bit about this environment that we're learning to program with. This is IPython, Jupyter, Colab, and Python executable. So what is it? Why do I care? How does this teach me to program in Python? Well, what's great about it is that this is an IPython-based shell, meaning that I can type in commands and instantly get back the output. Here's an example of putting this exclamation point and this Unix command ls. The Unix command ls will just show what's inside of a directory. And by putting this exclamation point in front, it allows me to execute that inside of Colab. I also can go through here and assign the results to a variable. And a variable is a way of storing data from the output of a command. So here we go. Here's this command here, var. And what's powerful about this is that this IPython environment gives me the ability to run things like grep. And grep is a command that will allow me to do things like search for certain things inside of a string. So this is a very powerful workflow that, don't worry if you don't understand all of it right now, we can get into it later. So this Jupyter environment that we're in is one of the best ways to learn how to program. And it's my recommendation for anybody that's learning to program is to start with Jupyter, because it eliminates needing to install software, get your environment configured, especially if you use the environment that I'm sharing with you, this Colab environment. So there's a few different flavors of Jupyter. One of the ones that you can be made aware of is this hosted environment here. So this Google Colab environment. There's Kaggle. So that's another thing that many people don't know, is that this is a hosted version of Jupyter Notebook. There's also just pure open source versions. So Jupyter, Jupyter Hub, these hybrid solutions, they'll run on AWS, they'll run on Google, they'll run on Azure. They're really I would say the language of data science, the language of programming nowadays is this notebook-based environment. So let me show you some of the key features of why I like teaching programming with it and also using it myself to develop code. Some of the key features are that you can upload both a TPU and a GPU runtime. You can upload regular Jupyter notebooks into Colab. You can have a whole drive of these. So you can treat these as like Google Docs or Google Sheets, and you can also sync these to GitHub. And so if I want to show you how that works, I can go here, go File, save this inside of GitHub here. There we go, save a copy in GitHub. And what it'll do is it'll wake up and make a connection to GitHub, and then I can sync this into my repo. So let's go ahead and select this functional intro to Python repo. Here we go. And if I click on OK, what it'll do is it'll make a copy of this notebook and check it in there for me. And that's how I'm able to share this notebook with you. So very, very powerful workflow that is really integrated directly into this Colab environment. You also, if you want to, you can mount Google Drive from inside of this Colab environment. And so if I ran this code, this would mount my drive here and ask me for an authorization code. And then from there, I could go through and I could list the contents of some part of my Google Drive. So this is a great way to store, let's say, data for your programming environment, or maybe to interact with something that you have in your Google Drive. So a great way to actually interact with storage. Another thing you can do with Colab is you can run these time-it commands. Here's an example of me running this time-it command that rounds off a decimal. So I can take a decimal, maybe this is from something in my math class, and I want to go ahead and round it off to 2 decimals. How would that work? Well, I can treat Python like a calculator. In this case, I also can time how long it took, and this will run it, in this case, 1 million times here. And it shows me that the fastest it was able to run it is 476 nanoseconds per loop. So it's a great way to test out your code and time it out, is to use this time it built-in command. And again, these are things that are available in this Jupyter-based environment. Another thing that can be handy is to create an alias. This is like a shortcut or a bookmark. And so in this case, let's say I always want to look at what's inside of my sample directory. And this is a directory that comes with Colab, and I want to see what's going on here. Well, one of the things I could do is I could make an alias called LSCSV, and then I could actually call that alias whenever I wanted. Here we go. So this again is a nice little shortcut that you can use to create these magic commands. Now, the next thing that I'm going to show you here is that there is a variable called who. And who is really interesting in that what it can do is it can actually show you what's loaded into current working memory. So in this example here, I have this variable 1, and if I type in the word who, it'll show me that I earlier made this variable, too many decimals, I made var, and I made var1. That's the one I created right here. And then if I just run the name of that variable, I can see directly what's inside of it. So this who variable here is a really powerful way inside of this Jupyter environment to see what's going on. Another powerful thing you can do is you can also use this write file method. And in this example, what I'm going to do is I'm going to use write file here, and I'm going to actually write out a bunch of code. Don't worry if you don't understand what this code means. The main takeaway here is that if you use this syntax, this will actually write out the contents into a file that you created. It could be whatever you want to call it. In this case, I call it magicstuff.py. And then from here, what's really fun about this is that you'll see that it created this file called writingmagicstuff.py, and I can run a Unix command called cat. And what cat will do is it will show me what the contents are of that file. So from here, if I go through and I run cat magicstuff.py, I can now use that as a script. So this is a great workflow to actually write scripts directly inside of the Colab environment. Now, if I go to this magic stuff and I run it in Python, and I can run that by using this exclamation point, you can see I also can run it as a script. So I can look at the contents, I can run it as a script. And another thing to point out about this exclamation point is this is a way to run any Unix command that you'd like. Is in this case, if I want to install, let's say, a lint tool, and what a lint tool does in Python is it checks the syntax and makes sure that your code is formatted properly and that it doesn't have any errors, and will give you warnings if it does. So in this case, I can run that script that I just created through this linting tool, and it will give me back the results of what happened. Here you can see that the line was too long, it's missing some spaces, and in this name, it doesn't correspond to a naming style. So I actually can configure that if I want to and make it more friendly. One other thing you can do in this Colab environment is you also can run just basic bash commands. So let's say you're coming from bash and you're trying to learn Python. Well, you can start off by executing some of your code in bash here. And here's an example. I actually have %% bash, and I go through here and I put a few commands together, and I can run this against my environment here, and I can see all the different outputs that come through. So there's a lot of built-in power that comes in this hosted Colab environment, and it's a little bit of a secret in that it's hidden inside of the Google ecosystem. Here's an example of me running a uname command, which shows me what version of Linux kernel there is. And one final thing that I can show you is this is an example of how to run Python 2. We're running the Python 3 interpreter, but there's an older version of Python called Python 2, and you can see that I can print out those commands as well. Another thing I can do is I can go through here and also run an HTML operation. In this case, if I use this %HTML, I can print out an HTML syntax right inside of Colab. So there's a ton of really powerful built-in features of this Colab environment that you don't have to do anything to. They just come with the environment for free. Now let's get into the Python executable environment itself. So one of the things that we've been doing this whole time is running through the Python command itself. And you can call it externally, let's say if you're in a terminal or another environment, and you can actually import modules. Here's an example of me using Python and actually calling the interpreter and importing different modules. And I also, if I wanted to, again, could install different libraries or even capture input. And we can get into this in later lessons. So let's get into the intro of programming itself. So that was really about the structure of the environment that we're in, but it really didn't show us anything at all about how to program, what programming is. One of the ways to begin programming is to get into procedural statements. Procedural statements are literally statements that can be issued one line at a time. And these are some types of procedural statements. They can run in Jupyter Notebook, IPython Shell, Python Interpreter, Python scripts. And this is one of the best ways to start with programming, is you just literally tell the computer to do something, and you can do it in a very simple way. Here's how you print something in Python. In this example here, if you go to the word print and we go through here and we print this out, this is a function. This parentheses here that starts it and the parentheses that ends it is the beginning and the end of a function. And inside, there's a string here that says hello world. And I can put in anything I want and it'll just echo it out. And that's really the basis of programming in Python, is to take functions and put things into them and make them do work. So here's another example of a variable where I could create a variable called variable, and then I assign something to the variable. And this is a way of storing things that you can reuse later. So let's go ahead and execute that cell. And if I wanted to, I don't have to make it armbar. I could make it some other word. I could make it, let's say, leg lock, for example. It doesn't have to be armbar. It can be anything we want. And that's one of the powerful things about programming, is you have the ability to create these abstractions and make things whatever you'd like them to be. And now if I want to change it back again, I can make it back to some other thing. There we go. Now it's armbar again. If I want to do multiple statements together, I could go and put one line into a variable and then have a second line in a variable. And this example, I have attack 1 and the word is Kimura. I have attack 2. This is a second variable. And I have the word arm triangle. And then I can print two statements together, and each one will use a separate variable. So this first statement says, in Brazilian Jiu-Jitsu, a common attack is, and then I go to attack 1 here and I print that out. And then I have a second attack that says attack 2, and this one has the arm triangle. And if I run this, it gives us each one of these responses. Another way to get started with Python and get started with programming is to just literally use it as a calculator. This is one of the best ways to get started. If I just type in 1 plus 1, here we have these two variables that are actually two numbers that print out the word 2. I can also put strings together. Here's an example of me adding phrases together. I have the word arm, I have the word bar, I have the word for, I have the word more stuff, I have the word lemon. This is a little bit of a nonsensical phrase here, but I can add together some sentence by just putting strings and putting them together. Finally, the other thing you can do with procedural programming, which is really a set of instructions, like if you go to IKEA and you read through a manual, it's the same concept, is you can write a for loop. And all a for loop does, and this is one of the more fundamental aspects of programming, is it just takes one thing at a time and it processes that one thing at a time in a loop. So I say for belt and belt. So basically for the white, for the blue, for the purple, for the brown, for the black, and it does it each time. It runs the same line of code. If the word black appears, then print out this phrase. So the first time it goes through, it does not match it. It says it goes through and it looks for that phrase. It doesn't find it. So it goes to this next phrase and it says, this is not the belt I want to end up at. And it says, this is not the belt I want to end up at, white. Then it goes through the next one, blue. And it says, this is not the belt I want to end up at, blue. Then it goes through the next phrase, this is not the belt I want to end up at, purple. Right? So it's processing these things one at a time. And this is really one of the most fundamental structures of programming. And this is a great way to learn to program, is just play around with this and put different things in there and even change around some of the things that happen inside of this. And you can see there's only a few lines of code. And it's a great way to learn the concepts of programming. All right, so that's really, in a way, almost enough for you to be really competent at doing a lot of different kinds of programming, because we've gone through creating variables, making procedural statements, printing things out. So let's get into a little bit more fun things here and format strings. So what a string is really just some characters. And in Python, one of the great things about strings is that there's all these ways that you get built into a string that let you do powerful things. So let's go through and let's collapse this cell. If I just go here, I can see what's underneath here. And you can see that my string, it says this is a string I'm using at this time. If I assign that to a variable, it will come up with many different operations that I get automatically. So let's first run this and see that in fact it does create this string. But let me show you how I can find out what's available there. So if I type in code here and make another code cell below here, I can take that variable that's created and I can put it in here and put the word dot. Once I do that in this Colab environment, it will automatically show me all the methods that I can pick. So I can kind of scroll through here. It's like I'm picking something I want to play around with. And let's just do this one. Let's go to lower. And if I go to lower and I put a open parentheses and a close parentheses like this, this will return a copy of the string converted to lowercase. And if I go down here, it doesn't do anything because I'm already lowercase. So I can just go through and find something else. Let's go through here and let's go dot, tab, or so dot, and then it'll automatically give me some other things here. How about upper? Let's go down. Let's say, here we go. Let's make them all uppercase. Okay. Let's make it open parentheses, close parentheses, shift return. There we go. And now they're all upper. So this is really the powerful part of programming, is that you do a little bit of work. You just put a string to a variable, and then the programming language itself has all these really powerful methods built onto it. I gave you an example of how you could make it uppercase. You could do title case. You could count the occurrences of this. And this is a very important concept in programming, is that if you're doing a lot of work, you're probably doing something wrong, because the language itself, especially a language like Python, it'll do all the work for you. So there's really very little work you need to do. Again, if I want to go through here and I try capitalize, here we go, I do capitalize. If I want to take that same variable and ask if it's numeric, you get the idea, is that I can go through here and do many different complicated operations just by using the built-in language itself. And here's an example of me swapping the cases. And I first start out with one case, which is lowercase. I print it out, then I print it out again, And you can see I swap back and forth. I can go over and over and over again and go back and forth between different cases. And this is just one of the powerful things you can do with strings. So let's go again and dive into this concept of strings into a little bit more detail. So this is an example of a basic string that I'm going to create. And I'm going to split this string. So I'm going to go through here and I'm going to split it up. And now what I'm going to do is I'm going to find out how many words appear afterwards, because this creates a list that has 3 different things. You can see from the beginning, this is 1 word, this is a 2 word, this is 3 word. If I run split, it puts it into a list here. And if I run the word len on it, this is a built-in method that shows me how many items are inside of a list. And so from here I say 3. And what this does is it allows me to get some insight into how I could maybe manipulate that data structure. And a data structure is just a container that holds things. So here's an example of I make a string that this time has hyphens, Brazilian Jiu-Jitsu. And if I run this, I can split it now on the hyphen. So you can split on anything you want. And again, I'm just using the power of Python itself. Here we go, Brazilian, there's a comma, Jew, hyphen, Jiu-Jitsu. And I can go through here and I can split it up as well. I also can go through here and I can capitalize a string as well. It's really endless what I can do. One of the other things that's powerful about strings is that you can slice them. So you can take off a piece of it or put a piece on one side to another side. And this allows you to do things like create a form letter or to manipulate something you grab from the internet and clean it up and get rid of maybe some characters you don't want. So here I take that same string and I say, grab only the last letter. And so this is the syntax I do it. I say -1, so go from the back and just grab me the last letter. And if I run this length operation, what this does is it says, give me everything but the first 2. And so what this does is it starts at the second part and then gives me the rest of the string. In fact, if you want to look inside what that would look like, a great way to test that out is to go above here, again, go to this code cell, add code cell, and just print this out. And if I print this out, you can see exactly what it's doing. It's printing everything but those first 2 letters. And if I run length on it, you can see there's 17 characters. But if I run it before I slice it up, you can see there's 19. So this is a great way to play around with how you can pull out little parts of a string and manipulate it. And here's one more way you could do it. You can go from either the front or you can go from the back. In this case, I go from the back and I grab all the letters up to 18 and then I stop. And that's what that looks like. So what else can you do with a string? Well, strings can be added together. So here's an example of I have a basic string and I just want to add some other string together with it. I just add these 2 together. I just use the plus sign. And if I wanted to, I could do something a little bit trickier, and this is called string concatenation, and I can use that same for loop concept, and I can say for everything inside of this list here, right, I have this, use this syntax, which is plus equal, which means every time I go through here, I want you to add something to this word. And you can see that it goes through and it creates the first string, and then it puts in a hyphen, and then it puts in a 1, and then it puts a 2, and then it puts a 3. So basically it appends each one of these items to this variable every single time I iterate through. Another way of handling something like that that's a little bit cleaner is something called string formatting. And this method that I'm showing you is called a printf formatting. And this is a very common way of formatting strings, especially in the C language. And you can see here it has a % and has an S. This % here, it takes this variable and it swaps it into here. One of the problems with this is it's a little bit verbose and easy to make a mistake. Like it's easy to forget this %, or it's easy to forget this %. So there's a much better way in modern Python. This is called f-strings. So that's the way I would recommend doing all your formatting, is to use f-strings. And the way it works is you put the word f at the beginning, and you put any kind of a phrase. In this case, I say, I love practicing my favorite martial art, Brazilian basic string, and then I pass in the variable. In this case, it says Brazilian Jiu-Jitsu 1, 2, 3. Now, you also can put even larger phrases together with these F strings, and you can see it's pretty intuitive in that you just put a word together or a phrase together, and you put a variable inside. And once you do that, it'll substitute out whatever your variable is into this phrase. In this case, it says this phrase is multiple sentences long, and it puts it all together. Now, one irritating thing here is that it has new line characters. Each time you wrap a triple quoted string, it puts this new line character in there. So you can use the power of strings again to clean this up. So if we go through here, we can use a built-in string method called replace. And I can say every time I get that new line character, put in some other thing in there. In this case, I'm putting in a pipe operator, but instead, probably what makes more sense is maybe I have a double space like that. And if I do a double space, then you can see that it says this phrase is multiple sentences long. Their phrase can be formatted like a sentence, right? And so it kind of makes it a little bit cleaner and allows me to build out a template. So this would be exactly the style that you would use if you were going to build out let's say you're a teacher at a university or a teacher in elementary school and you want to send out a letter to all the parents or all the students. You could build out, this is essentially, you're almost there in building on a form email, and you could generate a bunch of different responses and just replace out inside of your letter the name of the variable. And this could be the student's name or the parent's name. Now that's strings. Let's get into numbers and arithmetic operations. So in order to start with this, here's an example of using, let's say, a word problem. And this happens a lot in elementary school. You'll have steps. And if you want to add some things in parentheses here and then subtract things out and then put that into a word problem, you could say 2 steps forward, right? And that's the 2 steps, 1 step back, and that's the -1. And so at first, it evaluates the things in the parentheses, and this is how regular math works. And then I subtract that letter, and then I just take the result of that operation and I just swap it into there. So this is a great way as well to practice Python, is to do word problems. Here's another one that's a little more sophisticated, where I take the body fat percentage and I say 10%, and I take the weight and I say 200, and I say the fat total is the body fat percentage times the weight. And then I just print out the result of that word problem. And I say I weigh 200 pounds and the fat total pounds of that is fat. There we go. And I say I weigh 200 pounds and 20 pounds of that is fat. I also can use a decimal library, which comes in really handy if you're dealing with, let's say, elementary school style problems. Here I have from decimal, import decimal, get context. And then what I do is I set the precision level to 6. And then I just say decimal, and I put in the top of the decimal, the numerator, and then I do a divide, and then I put the bottom decimal, right, which is the denominator, and then it gives me back this variable. In this case, this is decimal, and it's 0.3333, and it's 6. It's at 6 units. And if I want to set the precision lower, let's say I only want to have 2 decimals, I just put in 2 here, and then it goes through and it sets it to 2. So really powerful library that allows you to deal with fractions, and this in itself is a reason to use Python. Even if you're not going to do any other thing with Python, is if you want to handle fractions in a really clean way, you can use this decimal library. You also can do exponents with Python. So here's an example of using exponents with the math library. I say import math, and I say math.power, and this is 2, which is the base, to 4. So I say 2 to the 4 power is 16. So this happens all the time as well if you're practicing dealing with exponents. There's even an easier way to do it in Python, which is you also can use the asterisk. And what this does is the same thing. So this is just a more succinct way to do 2 to the 3rd power, and that's 8. 2 to the 4th power, that's 16. You also can do regular multiplication in Python as well. You can say 2 times 3 is equal to 6. So this is, I would say, another great way to practice in Python is use math and get a comfort with Python by just practicing mathematical operations. Now, one thing that you should be aware of is that you're going to learn or need to learn how to convert between different types. And Python has something called duck typing, which means if it looks like a duck, it quacks like a duck, it's probably a duck. And what this means is that it'll automatically just do what probably you would want it to do. So in this case, there's a number, and this is 100, and I actually have a type built-in function here. And what this does is it'll let me know what kind of type it is. And in terms of numbers, the two most common ones are going to be integers, and this is just a whole number, or a float, and that's just a number with a decimal. So if I run this, first I have 100, then I ask what kind of type, and I assign the type to a variable, and then I print out the F string statement. So I say, here's my number, and that gets swapped out here, is type, and I take the result of that variable and I put it in here, and I can say 100 is type int, so it's an integer. And then the same thing applies with the line below. I say number float, and I specifically put float, and then I ask what kind of type it is because I use this built-in type method, and then I print out again this number, and you can see by hovering over it in Colab, it'll actually tell you what's inside, what's actually inside of a variable, which is a very powerful feature of the Colab environment. Next here again, I could also just assign a decimal, and then if I do that, you can see it becomes a float. Also, another thing to be aware of is fancier things, which we'll get into later, but classes, they also have types. If I go here and I put the word type around it, I can go through here and it'll show me what kind of type it is. If I want to do a function, which we'll get into in a second, let's just make a really simple function. Here, if I say def, and we'll do foo, whoops, here we go, def foo, and I'll do pass, and then I print the type of foo, you'll see that it'll say that it's a type of a function. There you go. Okay, numbers can also be rounded. That's another thing that I talked about earlier, but here's an example. I'm taking this really long number and I'm rounding it to 6. There's other third-party libraries as well that we'll get into later, but aren't that important to begin to learn programming. But this is a scientific library called NumPy, and it also can do rounding. There's also a data science library called Pandas, and it can do rounding. So how do you know which one to use? Well, one way to do that is to use what I was showing earlier, is this time it benchmark. So here's an example of going through rounding these decimals together, and you can see here that this shows that the fastest one, or this first one, is able to do rounding in 488 nanoseconds. This is 10 microseconds, and this is 1 millisecond. So this is actually the fastest method, and it's the built-in method. So you don't know these things unless you benchmark it out. And this is a little bit of an advanced technique, but it's important to know that benchmarking your code is a great way to test it out. All right, so we're almost done with the basics of Python. Now let's get into something called data structures. We've been using them a little bit, but basically they're like if you go to the grocery store, you have the cart you can use that has a lot of stuff it puts inside of it, or you have a basket that you hold in your hand. It's kind of the same thing with Python. Two of the most popular ways of handling and putting things somewhere are lists or dictionaries, and they're really the workhorse of Python. So let's start with a dictionary here. And so to create a dictionary, really they're pretty flexible, but there's one thing you can't do with a dictionary, and that's put a mutable object. So you can't put something as a key, something that will change. And so if I go here and I create a bad dictionary, this is a list, and a list is mutable. It means I can change that list. And if I run it, it'll say unhashable type list. I can't do that. Other than that, dictionaries are very flexible. The reason why you can't put something that changes in there, like in this case, this is going to stay the same, is that the way a dictionary works is that no matter if you have one item or a million items in it, if you look up the key of the dictionary, in this case, this is the key, it'll be the same amount of time to retrieve a result. So that makes it a very fast data structure. So here we go. I make in the word 1. If I want to make a bigger dictionary, here's what I do. I just say key, value, key, value, key, value. And you can see that it prints out the key and the value. There's a second way you can create things, a dictionary in Python, and that's this dict built in here. And what this is the built-in function that also lets you make key value pairs. The most common way that you'll see people make dictionaries though is this, and it's pretty straightforward. You just have brackets, you have a string, a colon, and a string, and then a comma. Let's go ahead and use these dictionaries now. So one of the ways that is really common to use a dictionary is that you pull the key out and the value out, and you say submission.item. So you put in whatever the name of the dictionary is, and then you call a built-in method called .items. And what this does, and again, I can highlight over this and it'll show me what's inside of it, is it has the key, which is armbar, and the value upper body. So I can now put a print statement down here, and it says the submission is an attack on the body part. So for each one of those key value pairs, it's going to print out a word. It's going to say the armbar is an attack on the upper body. The arm triangle is an attack on the upper body. The heel hook is an attack on the lower body. So it's a great way of pulling things out of a dictionary and putting them into, again, let's say this is a form letter. You also can use a dictionary to filter. So this right here, this underscore, what this does is it throws something away. So in this case, if I don't want that key, I can just throw it away. I can just put this underscore and it won't do anything with it. And I just want the value part of it. And I can say for the key, which I throw away, or the value in this dictionary, submission.items, just print out the value. In this case, you can see it prints out upper body, lower body, lower body. And again, if I hover over this, you can see what's inside of here is that, or let's hover over one of these, there we go. We can see the armbar is the key and the value is upper body. Armbar is a key, value is upper body. Heel hook is the key, value is the lower body. And so it does that exactly right here. If I want to filter here, the way to filter would be to look specifically and do an equality statement. And this equal says every time the word lower body appears and and this value is equal to it, then print out the key. So in this case, there's only 2 that have lower body, right? And so it's going to print out the key that's associated with it. So in this case, this is the heel hook and this is the knee bar. These are the lower body submission attacks in Brazilian Jiu-Jitsu. So it's, again, a great way to filter things out. Let's say you're a teacher and you're printing out a form letter and you have some things that need to go to the 3rd graders, some things that need to go to the 4th graders. You could go through here and say, if the grade is 3rd grade, do this thing, print out this letter. If 4th grade, print out this other letter. One other thing to be aware of with a dictionary is that they have also built-in methods called .keys and .values. Here's an example. If I say, these are keys, and I put in submission.keys, these are values, submission.values, I can print out what's in the keys and what's in the values. And I also have a way of looking up, doing like a membership. So basically, if you can imagine asking someone that's an alumni of your school, do you belong to that school? And imagine if you could immediately ask whenever you wanted and you could find out whether someone was or not. It's a little bit like how LinkedIn works. I could say, if the word armbar appears, just print out some statement. And this is a very fast method. It could work, it'll be the same amount of speed as if you had 1 million or 10 million items in there, as long as they fit into the memory of your machine, as if there's one item. And this is what makes dictionaries so powerful, is that they're very, very fast. And again, if I print this out and I time it, you can see here that 33 nanoseconds is very fast. Okay, so dictionaries are a very powerful workhorse. They're used all the time. What about a Python list? Let's get into Python lists. So lists are also a very commonly used structure again in Python. And again, think of maybe the cart, like a grocery cart is the dictionary, because it actually has a lot of stuff you can put in there, and it's most commonly used. And then a list is a little more of like a bag. Like you just put some stuff in the bag. In this case, here's our bag. We're putting some words in there. It's a list of positions. That's probably the most common way, is you put this brackets around it, these square brackets. But you also can define a list as well by using a built-in method called list. And then you can append things to it. You can say dot append and put a couple things inside of there. So here you can see this the same way. There's even a third way that you can create things with a list, and this is called list comprehension. Here we go. We've got full, half, open, and I say for guard in guards.split. And this is what this is the backwards loop. So just really ignore this part of it for a second. And what this does is it says for guard in guards.split, then go ahead and do this. Why do people do this? What do they care about this method? Is that this is highly optimized C code underneath the hood. And if you're running on millions of items, it can run much, much quicker than just regular Python. Okay, now let's talk about using a list in Python. So one of the easiest things to use, you just say for item inside the list. So for position and list of Brazilian Jiu-Jitsu positions here. And again, if I hover over it, you can see it inside its mount, full guard, half guard. If the word open appears, it's a partial match as well. And in this case, we can see here that we can't see all the items, but it's going to go through, and if it finds that word, it'll print out just the match that matches that. And there we go. There's the word open guard. You also can do slicing. Remember, we talked about that with strings. They also work with a list. I can pull things from the back, from the beginning. I can even pull maybe a sequence, like just a few of them together. And here we go. Here's the first position, which is mount. Here's the last position, open guard. Here's the first three positions, mount, full guard, half guard. You also can do some kind of tricky things with a list. And this is not something that's really important to know about, other than if you want to play around with some fun things, you can transpose the lists and make them a different way. So in this case, you can see that the top row is dominant, top mount, back mount, side control. I can swap it, right? There's 4 by 3, and now I can make it 3 by 4. And look, dominant, top mount, back mount, side control. So if I run this list zip operation, I can transpose things. So you can also do really fancy things with lists as well. All right, so the less commonly used data structure, there's more than just lists and dictionaries. There's also sets and some other data structures. But let's go ahead and briefly talk about sets, because they're also kind of handy. One of the nice things you can do with a set is that it can deduplicate a sequence. So here we go. We've got a sequence. We've got armbar, armbar, armbar 3 times. We've got kimura, kimura. If I just put it inside of a set, it'll dedupe it. And in fact, what we find here is that there's only 2 things that are unique, armbar, kimura. So that alone is a really useful tool, because you could pass in, let's say, a customer list or some kind of structure that has a whole bunch of duplicates in it. All you do is pass it into a set, and it comes back with the unique values. And also you can do some pretty tricky things inside, like you can subtract one set from another. So you can say, okay, here's my first set here. Here's got armbar, kimura, heel hook. Here's my second set here. This is toe hold, knee bar, heel hook. And I'm going to make a unique set of the one attacks. And I'm going to take that first one and I'm subtracting from the second one. And this just shows you what's unique from that subtraction. So there's some pretty tricky things you can do with sets as well. All right, so that's the data structures. You're almost done becoming a Python programmer. Let's now get into functions. And really from here, really what's important is if you don't know all of this stuff, it's really not a big deal. You just need to know how to write a function, put things into it, and then return things out. There's some really fancy things we're going to do with functions. And if you don't understand it on the first try, just rewatch the video and also go through these code examples, but they're kind of optional to be a Python programmer. Let's go ahead and start here with Python functions. I'm going to go through here and first start with a function. This is really the essence of programming. And here's an example. So I to create a function, I put the word def and then the name of the function, a open parentheses and a colon, and that's really a function. In this case, though, I return back this string Brazilian Jiu-Jitsu. Okay, let's go ahead and run that. And now, if I print this function out, and to call a function, you just put this open and close bracket here. You can see that it's basically the same as a variable. So why do people write functions? Like, what's the point of a function? Well, that's not why you would write a function. And I'm going to show you why you would write a function. Let me show you one last thing, though, is that the simplest possible function you can write is a function that does nothing. And it turns out that that's completely useless and you never will do this. But just for the sake of showing you, if you want to write a one-line function that does nothing, that's how you do it. And if you go through and you print out what's the result of that one-line function, you can see it does nothing. So now let's get into making some functions actually do something useful. So to start with, what we're going to do is we're going to add some documentation to a function. So we'll take that same kind of easy structure we had before, but we're going to put the triple quoted strings in here, right? So this is a way of making a string that has many different statements inside. If I do this, what's fun about this is that I can attach a message to a function. So how do I actually use this? So in this example here, if I run this, if I run shift return inside of the Colab notebook or Jupyter notebook, it'll pop open a help message. So this is a great way to communicate ideas to other people and to let them see how your code works. You also can use doc, and that's another way of printing out the same thing. So let me show you how that works. So if I go through here and I print this out, I also can print out the documentation that way as well. Okay, so that's the documentation. Now let's actually use a function. A function is most useful when you actually pass things into it and make it so that it's reusable. So it's a lot like a car. Like if you had a car and every time you used it, you drove it off into a cliff, it's not going to be a very useful car because you only can use it once. It might be fun to drive it off of a cliff, but it's not going to be that useful. Instead, you want to put different people and go to different locations. The function's the same way. We're going to make a function here that accepts the word times. And inside this function, I'm going to put this phrase. This is going to use the same f-string format that we used earlier. I like to practice. I take the word times and I swap it out. So let's go ahead and run that. Next, what we're going to do here is I'm going to run this practice function here. In this case, I say I like to practice 2 times a day. So you can see it's changing the behavior because I passed in a new value. I can now pass in 3, right? And so this is really what makes a function useful, is that you can make it do many different things depending on what it is you pass inside of here. And this is a great function to play around with to make sure that you understand how a function works. Now notice this doesn't return anything. It just does something. Okay, now let's get into positional arguments. These are arguments that are processed in order. So it's going to be processed left to right. So if I make a more complex function here, and in this case I like to practice, and it's technique times a day for duration minutes, you can see that I can actually go through here and I can pass in different parameters into this function. So I can say, if I run this, I can say practice 3 piano 45. So now I have a generic function here that says I like to practice the piano, which is the technique, 3 times a day for 45 minutes. Well, that's kind of a useful thing, and I could change it if I want to. I could change this to 4, and I could change. Let's change this to 4. Let's go through here. Change this to 4. There we go. And I could change it to some other thing, like I could change it to, I don't know, jump rope. Okay. There we go. And if I do this, what it's going to do is it's going to allow me to change the structure. So it's pretty useful function still. But one of the problems with these positional arguments is that they're processed in order. And so if I go through here, and I put in the word piano first now, and then the 7, the 60, it says I like to practice 7 piano times a day for 60 minutes. Doesn't really make sense anymore. So we got a problem. So how can we fix this? Well, one way to fix this is by using keyword arguments. And this is a way of storing the order and storing default values. And in this case, if I type in this phrase, this function, def practice, and I have 2, and I use the equal sign, this sets a key value pair. So this is a dictionary. And then technique is equal to Python duration. So now I can run that same phrase. And if I run the function, which again, I call it with an open close parentheses, this will say, I like to practice Python 2 times a day for 60 minutes. Next, I go through here and I say practice. and I put in duration 90 times 4. I like to practice Python 4 times a day. So you can see I can even swap the order around. And this is the power of keyword arguments. So really keyword arguments to functions make them the most valuable. And again, remember, this is not returning anything yet. It just does something. Now, another thing that you can do is you can also dynamically pass in an arbitrary amount of things into a function. So here's an example of how that works. I use this syntax ** keyword args, and this accepts literally any number of arguments. It could accept 2 or it could accept 2,000. And what I do is every single thing that's printed that comes in here, I break it up into a name, a key, and a value, and I use that items method, which is what a dictionary uses, and I print out this phrase. So let's go ahead and run that. And from here, if I go through and I run this attack technique, arm attack, leg attack, neck attack, body attack, from here, I can go through and basically run any number of these attacks, and I could put in, again, 2, I could put in 4, I could put in whatever I want. So here, in this case, I had 4, but what if I want to put in 5 attacks, right? You can see how now, again, functions become really useful because I can reuse them. I only had to write this code once, but I can use them for many, many different things. Probably a cleaner way to do that, though, because it can be a little confusing, is to just pass in, if you are going to take in arbitrary keyword arguments into your function, is to maybe pass in a dictionary, and then it's a little bit cleaner to see exactly what's happening. Here we go, and I pass in this dictionary, and I can process all of those. Okay, so that's a function, but we're really just making the function somewhat simple, and that it just does something. But what if we have the function do something and return something as well? So it would be a little bit like that car example, where what if you had a car that took someone somewhere, and that's what our function is doing, is just taking us. But what if it automatically came back and it returned something automatically, like a self-driving car? Well, let's take a look at how that would work. So here's a function that what it does is it accepts a technique, and it has a list of attacks, and it looks through that technique. And if it finds a technique that appears in this dictionary, it will return back what kind of technique it is, right? So if it's a Kimura, it'll say it's an arm attack. If it's a straight ankle lock, it'll say it's a leg attack. Let's go ahead and run that. And now I just pass in this attack location. In this case, this is a Kimura. Here's a second one, attack location, bear hug. This is a wrestling move. And it turns out that this thing doesn't understand what that is, so that's why it returned back this statement. So this now gets into the most powerful part of a function, is not only can it accept something, but not only can it process something, but it also can return something. And so what that means is that you can use the return value and pass it into somewhere else. So let's take that function and let's pass that function into another function. So here we go. Here's multiple attacks, and here's the name of the function, attack location function. And this right here is a new attack list, as a list is rear naked choke, Americana, Kimura. I say for attack in new attacks list, take this function, which I don't know what it is yet, but someone's going to pass it in, and find out what the location is of the attack, and then print it out. So this is how you can chain together multiple functions to do more sophisticated techniques. And what's powerful about this is I didn't have to change either function, right? And I didn't have to go change that other function to make this code. I just reused something that was already written. And this is now getting into the more sophisticated parts of programming, which is making things reusable. So let's further go down this road. And I would just, a little note of caution is that right here is probably a good enough spot where if you don't understand the next part of what we're doing the first time you see it, don't worry about it. If you understand up to the point that you got to right here, you're in great shape and you have a lot of skill under your belt. This next part is fairly complex, and it's going to take a few viewings for most people to understand it. Okay, let's get into closures and functional occurring. So what this is a way of having a function that has a hidden function inside. So it's basically it would be like a sidecar on a motorcycle. So you have a motorcycle and you have a sidecar. It's kind of hitched on for the ride. So what this one does is this function here has inside of it another function. It's nested. It's kind of attached here. It's like a little parasite. And we have a lower body counter and an upper body counter. So we have two variables that this lower function is going to use and mutate. And so what I do is I assign this word non-local. And this means that it can only mutate just one level above it. If I put some variables up here, it wouldn't work, but it will work inside of this outer function. And what this is going to do is it's going to look in whatever I pass inside of here. It's going to look to see if that attack is a upper body attack, like if it's in this list, or if it's a lower body attack, and it's just going to increment out. So it's basically going to permanently keep track of whatever I pass into it. So it's like basically a great bit of code maybe to build a video game. Like if you want to build your own Python video game. And so I go through here and I print out every time somebody passes something in here, what happens. And then here's the part that's a little bit complicated, is that this inner function here, which is attack filter, you can see that this outer function returns the inner function. So let's go ahead and tee this up. There we go. And now what I'm going to do next is I'm going to make that outer function return the inner function. Okay. And now it hasn't done anything yet because I haven't passed anything into it. Now I'm going to pass in some kind of an attack. Here we go. Kimura. So now it prints out that I passed in one attack. Now I can call it again. And this second one will show me that the knee bar is a lower body attack. If I call it again a third time, it's going to say that you gave me 2 upper body attacks and 1 lower body attack. So this shows you some of the real power that you can get by combining functions together and using something called a closure. And this is a completely encapsulated function that I could pass around to, let's say, 1,000 different machines. Let's say I was building a scalable video game system that wanted to use, 1 billion different people at the same time were going to use it. Well, I could build this. This could be the building block of it, and I could distribute this function across 1 billion different processes, and all of them could be running at the same time, and each one would be separately able to calculate the attacks that are passed in. So that's one of the powerful things about functional programming, is it's all kept inside of the state of one particular function. Let me show you another thing you can do with functions here. Here's an example of using a partial function to partially call a function. And what this does is it allows you to take a function and not fully execute it. So in this case, I can say from functools partial, and it's really simple function. All it does is it accepts 2 things and it prints them out. But if I put the word partial, what this does, it allows me to essentially use it partially. So if I pass in one thing, it's not fully completed. It's kind of ready for me to fully execute. And so if I go through here and if I pass in the second variable here, because I first passed in Kimura, then it fully executes. And that's really one of the more interesting things you can do as well with functions, is you can use these kind of delayed execution techniques. So finally, if I want to call the original function, I also didn't change it because this partial method was able to change the behavior of a function. Now let's get into something that is really useful for big data, and that's generators. And generators are a style of programming that allow you to handle infinite sequences. And by infinite, I really mean infinite sequences. Here's an example of a function that imports the random module, and it has a bunch of attacks here. And this statement, while true, it will randomly pick some attack here and pick one of them, and it will yield back one of the attacks. And what the while true statement does in Python is it will run forever. But I have a little bit of a trick here in that I run this special word called yield. And what that does is it tells it to yes, run forever, but only run when I tell you to run. So what this means is I first tee up this function, and if I look at the type, you'll see it's returning back something called a generator. And what a generator does is it's lazy. It only runs when you tell it to run. So I guess it's like the utility grid. It's basically gonna, if you turn on the power, then you get the power, but it's waiting there ready for you. If I run it again, you can see I've got another 6 attacks. If I run it again, I got another 6 attacks, and they're always going to be different, and it will run forever. I could run this forever and it'll always give me back new results. And this is a way of handling infinite data. So imagine if you had an infinite stream of data and you wanted to sample it forever, this would be a great way to do it. You yield out a little bit of it and you randomly pick some of it, and then you just print out a little bit at a time. And the way I can handle that is by using this next operator. And that's the way you tell a generator to get a little piece of it. So that's a pretty complex topic, and it's worth playing around with on your own. But let's get into something that you'll see a lot in Python called a decorator. And a decorator is a function that wraps another function. And that's really all it does, is it just takes one function, does some stuff to it, and returns it back. And here's an example of a randomized speed attack decorator. And what this does is it imports time, imports random, and it accepts another function. And the function gets in here, I add some sleep in there, and then it returns back the original function and the original arguments and keyword arguments. So let's go ahead and run that. And now if you go through here and you put that decorator on top of a function, that same function I just built, in this case, look, you can see the way you put a decorator on there is you just put this @ symbol, and then what it tells this decorator is basically slurp up this function, spit it through here, and then return it back out again. And so if I run that, what's going to happen now is that it's going to randomly put in some sleeps in there, because that's what that decorator does. So everything's the same. It still runs forever, except for it randomly has some sleeps. And so no matter how many times I run this, I'm going to randomly get slightly different results. So a decorator is a very powerful functional concept as well. Okay, so now let's move on to one more kind of a decorator, which is a timing decorator. So if you're confused about decorators a little bit and you want to get familiar with them, this is by far the best way to do that, is go into this decorator syntax here and use this particular setup. So I use from functools import wraps, and all this does is just preserves the name of the function it wraps. And so that's the only thing to be aware of there. And again, this takes a function, that's what this f is, takes the arguments, take the keyword arguments, it times it, that's where this comes in, and then it prints out the name of the function, and it prints out the arguments and the keyword arguments. So it's a great way to kind of debug code, is to use this wrapper, and you could tweak it yourself. You could change it, make it do other things. So let's go ahead and take that timer. Now let's put that on top of that other function. And you can see here what happens is it goes through, it runs those attack, and look, it finds the name of the function, which is called some attacks, which is what I built there, and has the arguments. There's no arguments, right? There's nothing passed in. There's no keyword arguments. There's nothing passed in. And it shows me how long it took. So really fun and powerful method to use is these decorators. Okay, now let's get into some other tricky things you can do with functions. Is you can make a class behave like a function. And later we'll get into classes, but the main thing I want to show here is that this is a class. Just pretend that you know how it works if you don't. And if you put inside of here this call method, you can basically tell a class that it should behave like a function. So let's go ahead and run this. And if you scroll through here, I can tee up that class, and that's what this does right here. And I pass something into there, and this initializes the state, and then I can call that class as a function. Now, this is a little bit of a tricky technique that really the main purpose to use this is if you wanted to initialize some state and then treat this like a function, that would be the best way to use this. So why am I talking about functions so much and passing things around and lazy evaluation and all this? Is that for data science in particular, it's one of the more powerful techniques to use. And so in Pandas, which is a data science library, a lot of times the only way to operate on something is to use a function and apply it to a data frame. So here's an example where I use the Pandas library. And again, think of it as like a fancy way of processing a CSV file or Excel file. I use pd.readcsv and I pull in some CSV data. This could be, in this case, this is data about flowers, but it could be spreadsheet data about your company's progress report. I go ahead and I run this thing called shape.shape. And what this does is it shows me that there's 150 rows and 5 columns, right? Let's see here, 1, 2, 3, 4, 5. And so by one of the things that you'll want to do to apply a function is if you say apply, what I can do is I can say I'm going to create a new column in my spreadsheet. We'll again call this a spreadsheet or columnar data. And I'm going to take this existing sepal length column, right? It's this column up here, which is sepal length. And I'm going to round it, and I'm going to put a new column together that has only the random data. So this is the way, this is a function, this round function. Now look, I say rounded sepal length. Look, it rounded all those values. So kind of useful, but let's write our own function here. And if I say shape here, you can see that now it added a 6th column. So where it really comes in handy though, is when you have to write your own function. And so now let's take all those things that we learned earlier. And here we have a function called multiply by 100. And what it's going to do is it's going to accept some value. This is going to be an X. And we're going to multiply whatever's passed in and return it back again. That's it. So it takes a value in, multiplies it by 100, passes it back out. And what I'm going to do is I'm going to take this multiply 100 and I'm going to make a new column in my spreadsheet or my columnar data. And I'm going to again look at that sepal length column and I'm going to do dot apply. And what this is going to do is it's going to, for every single row in the data frame, in this case, there's going to be 150. It's going to multiply the values of the sepal length value by this function. And that's where functional programming really shines, is in data science, distributed computing, and machine learning. So let's go ahead and run this. There we go. And now look, we have 100 by sepal length. And now, do you believe me or am I just making this up? Well, let's comment this out. And what you should see is 150 outputs here. Let's go ahead and run this. And there we go. And you can see that every single one of these, it went all the way up to 150. It passed out these values. So this is a very, very powerful style of programming that comes in very handy for data science. So that's really it. That's a fast tour through learn to become a Python programmer. You can use this same notebook, which again is located in github.com. Noah Gift, Functional Intro to Python. This is day 1, part 2. Later, I'm going to go into day 1, part 2, and I really appreciate your time.